Alright guys, welcome to Chapter 9 of the Digital Investigator's Handbook. Today we're going to be focusing on investigating web and application attacks. The main objective for this module is to look at things like server logs, identifying SQL injection, and cross-site scripting attacks. And then we'll finalize on web shells. Now, for the CHFI exam, understanding the investigating of how to investigate web application attacks is going to make sure that you're familiar with the OWASP top 10 vulnerabilities. A forensics investigator's primary role here is to do post-incident analysis. This is going to help us determine things like the vector of compromise, establish a timeline, and assess different things like the extent of the data exfiltration itself. Now, our learning objectives for this module are going to be broken up into 3 different key areas. The first area is going to be the server analysis. We're going to learn how to analyze IIS and Apache logs to reconstruct attacks and user activity. We'll then move on to attack signatures, where we're going to learn how to identify signatures for SQL injection, cross-site scripting, and directory traversal directly within a raw log data. We will discuss how to detect and investigate malicious backdoors that attackers are going to use for those persistent access through web shells as well. Now, the exam itself is going to frequently test your ability to read raw text logs. You should be able to differentiate normal user traffic from malicious scanning or exploitation attempts. Okay, simply by looking at the URL, string, and HTTP status codes, you should be able to tell whether or not it was an attack or not. So to investigate an attack, you must understand the architecture of the environment. The standard is the 3-tiered model, and evidence can exist in any of these 3 tiers. Now, the first tier is going to be the client, the presentation tier. Evidence includes things like browser history, cookies, and cache. The next tier is the web tier. This is the logic tier. Now, evidence is going to be found in IIS, Apache logs, or application logs. And then lastly, we have the database tier. Now, evidence resides in SQL transaction logs and modified tables. Remember, that's only if there's a database involved. Now, understanding exactly what type of forensics artifact is left in each tier is going to be extremely important on the exam. For example, knowing that a user session token might be found in a client's cookie file, while the query that extracted the tokens could be found in the database transactional logs. Now, web attacks leave traces everywhere in the infrastructure. They're going to provide us multiple sources of evidence. So the first place we should check for a web attack is going to be the web server logs. This is going to be the primary source, and this is going to record everything, including all the requests, all the responses, including IP, time, URL, and status. For our exam here, just remember that we're using Apache logs, so we may want to look at the Apache logs within the WAMP service. Now, the next log is going to be the application logs. Now, these are custom logs generated by the application itself. Like maybe they had a login portal, so they may have a failed login for user X example here within their application log. And then lastly, after you're done looking at the web and application logs, let's look at the network traffic. So PCAP data from firewalls or even intrusion detection systems will show us the attack payload in transit. Now, you're going to need to be familiar with the tools used to capture and analyze network traffic, such as Wireshark. The exam will expect you to know how to correlate a PCAP packet timestamp with a server log timestamp to build a cohesive timeline. So the first place we're going to look is going to be the server logs. Think of this like the black box of the server itself. Now, the answer key is always going to be the who, which will give you the source IP address, the when, the time and date of the request, what did they request, including malicious payloads, and the result of the code. If it succeeded, remember, a lot of status codes with HTTP for a success will be a 200. Now, normal traffic will show up as a 200 as well, but if we see a ton of things like 503s, like forbiddens, and then all of a sudden an attack success, maybe we need to check into that, especially if we're basing off a certain source IP address. Now, be aware that the post request bodies, which might contain passwords or uploaded file content, they're normally not logged for security purposes. Now, as an exam prep note, there is a limitation regarding post requests, and it's a very common concept for the exam. Attackers are going to exploit this blind spot by placing their malicious payload in the body of an HTTP post request to hopefully bypass simple log-based detection mechanisms. So they may use an HTTP post request to hide their malicious payloads, and that's highly tested upon on the exam. Now, when analyzing Microsoft IIS logs, you should know where the default location is going to be. It's normally going to be found in the system drive, which could be the C drive, inetpub, log files, and then W3 SVC1. Ooh, it's pretty much the only file inside that folder, so it's pretty easy to remember once you're there. Now, they're going to utilize the WC3 extended log file format. That's why they call it a W3 service, okay? Because they're going to be using that W3C extended log format. Now, the fields that you can find here is going to be, for one, you're going to see the client IP, the method, whether or not it's a GET or a POST, the actual page requested or posted to is going to be the URI, and the returning code. Now, that returning code could be a 200, 503, whatever it may be, remember. Maybe even be some 404s if page not found. So you need to know for the exam to memorize the location of the IIS log. You need to be able to parse through a W3C log on the exam and basically be able to read it, okay? And so if you haven't been able to do this before, you do need to pull up a log and actually see it for yourself. The best place that I try to remember this inetpub file is where I'm going to find the log files, okay? And that's for IIS. Now let's move on to Apache. So Apache and Nginx logs are a little bit different. And so for this class, we're running an Apache server within a Windows machine. Now, Apache initially was developed for a Linux environment. And so you normally would find those logs in var log. But just know that it may not be only in the var log directory. We may have to go into the application directory and find the log directory from there. Now, you are going to find some logs here, and they're generally going to be in the common log format, the CLF. Okay, and here's an example of a CLF. It's going to request all the files from whomever was accessing it. And then the error log itself will actually have diagnostic and errors. And this is critical for debugging things like crashes of a system. So the access log is great to look for those externals, while the error log is going to be great for diagnostics. And if we read this, you can see that, hey, from 127001, Frank accessed this box at this timestamp, and it looks like he went and got a apache_pb.gif file. Now we notice it's an HTTP request, which means it wasn't secure, and it was a 200, which means it was successfully given to Frank. Okay. Now, IIS and Apache and Nginx, those are going to be the three main ones that you need to know for the exam. There are others out there, but they don't test on these, okay? They're going to test on what is normally found in the wild. Now, Apache is a very common web service because 93% of all web servers are Linux-based, so you're going to find a ton of those, but you may even come across some of those IIS logs. Now, for the HTTP methods, you do need to know the difference between a standard method and a dangerous method. And the standard verbs are going to be like get. Get will request data with parameters in the URL, and that's going to be logged like normal. Now, post, on the other hand, is going to have the client send us data to the server with parameters in the body, but often these are not logged. So post is one of those things that aren't often logged. Now, there are going to be some head requests. This is only going to be the headers only. And it's normally used for reconnaissance. So sometimes when you see a ton of head requests, it means there's somebody out there looking for some weaknesses within our servers. Now, some of the dangerous ones out there are going to be like put, like uploading a file to the server, delete for deleting a file on the server, and anything that says options, where the server are saying, hey, what methods are allowed here? If a browser is asking for the options, it's looking to do one of these two things normally. And so if you see options, again, it is a telltale sign that somebody's looking for something. Okay. Now, understanding how those HTTP methods work on a CRUD operation. So if you guys don't remember what CRUD stands for from your Security Plus, CRUD remember is create, read, update, and delete. Basically, any of those operations, we need to be able to understand how those are working, such as put, delete, post, and get. And remember that misconfigured web servers may allow us to put or delete files directly on the server. And now attackers will be able to use these methods without relying on any complex application vulnerabilities. In other words, they don't really need a hacker system. You just let them in. HTTP status codes is going to hold a lot of information into determining whether an attacker was successful or not. So you do need to know these codes when you're reading the logs. The first log is 200. This means the request succeeded. It's only dangerous if it's trying to execute things like cmd.exe. That's kind of bad. We don't want that. But if we see a bunch of 200s, it could just be someone browsing our web page. A 301, 302 normally means the user was moved. It could be a phishing link or something like that. Now be aware, this is also common for login forms to do on a normal day and basis. So 301 and 302s aren't always a bad thing, but it's something we want to check into to make sure that all the 301s and 302s that we see for the redirects are expected on our web application. 401 and 403 are normally unauthorized. Basically, they're trying to brute force us. This is just indicating that somebody is trying to generate or to log into our servers, okay? Normally 401 or 403 means either a failed login or an unauthorized attack. 404, traditional not found. If you see a ton of 404s all within a short period of time, it could be a scanner like Dirbuster, and these can generate a lot of noise inside of our logs, all right? And then lastly, we've got an error 500. Error 500s are bad. This normally means that we have a crash within our system. We don't want to see 500s. If we do see 500s, is there a problem with the application or is somebody attacking us? Now for exam, thoroughly memorize the HTTP status codes for our 100, 200, 300, and 400, knowing that each one of these codes means something. So anything with 100 normally is informational, 200s are successes, 300s are redirect, 400s are client errors, and 500s are server errors. Now you may have to look at a server log within the exam and deduce the outcome based solely on these numbers, even if you don't know what they mean. All right, the first type of attack that we normally see within a web application is going to be a SQL injection attack. So we're going to look at that attack vector, specifically SQL injection. The concept is going to revolve around manipulating the database query by injecting malicious SQL commands in input fields. The attacker's goal is to bypass authentication, steal data, or even delete tables. The potential impact is a full database compromise. So you're going to need to be able to differentiate an in-band SQL using the same communication channel for the attack and gathering results, or a blind SQL channel, which is inferring that the database data is either true or false based off of time delays. And then you also need to know out-of-band SQL. So there's three types of SQL attacks. So if you are going to take the Certified Hacker Forensics Investigator exam, just know that you're going to need to know in-band, blind SQL, and out-of-band SQL injection attacks. Okay, if you haven't had experience with these, I do highly recommend doing them. Those who have taken my pen test class, we've done a few of the in-band and even out-of-band examples. I don't think I've ever done a blind one in class for you guys, but that's talking about very advanced SQL injection. Also remember that input validation is something that we're going to be using to help prevent these types of attacks. Now, when hunting for SQL injection in logs, we're going to be looking for SQL keyword terms and URL strings, just like you see here on the screen. So you're going to be looking for those single quotes, going to be looking like comment strings, or even keywords like union, select, drop, or even an XP command shell. Okay, so we need to be looking for that. Now, for the exam, XP command shell is a stored procedure in Microsoft SQL Server, and it allows us to execute window command prompts through the database. So if we can see this in a log, it indicates that the attacker is attempting to escalate from database access to OS level remote code execution. Normally, this is their way of getting an elevated privilege to the machine itself. Next, we're going to be talking about cross-site scripting, and this is involving injecting malicious scripts into web pages. Now, these web pages are normally going to be viewed by other people, and the ultimate goal here is to execute scripts in a victor's browser to steal their session IDs or redirect them to a malicious site. And for the exam, you must be able to distinguish between the three types of cross-site scripting: stored cross-site scripting, reflected cross-site scripting, and DOM-based cross-site scripting, and know the differences between each one of these. And as a quick review, remember that stored cross-site scripting is when the payload is permanently saved on the server's database. So they may put it in a comment form, and that's where it's stored. Reflected cross-site scripting is a payload is bounced off the web server and is an immediate error or a search result. So basically, we're reflecting it off of another machine. And then DOM-based cross-site scripting is purely within the client-side browser without even hitting the server itself. A lot of DOM-based cross-site scripting will be something like JavaScript because it's ran 100% within the client machine. Now, what are those signatures going to look like for us? Cross-site scripting log signatures are relatively easy to spot as long as they're not obfuscated. Okay, so if we look for HTML tags or JavaScript within input fields, normally we can find that there might be some cross-site scripting here. So we're going to be looking for like div tags or brackets, and those would be some of those HTMLs. We may be looking for event handlers like onload, on error, on click, or we'll be looking for functions like alert or document.cookie. A lot of that is JavaScript, okay? Now, attackers are frequently going to use URL encoding, so like %3c or %3e to bypass simple application firewalls. Now, a forensics investigator must know how to spot and decode these strings, so we may be actually searching for these within the logs to see, are we dealing with some obfuscated cross-site scripting, or was it just put into plain text? Now, directory traversal happens when the attacker attacks or tries to get access to files that they're not supposed to. Basically, they're looking outside of the root directory. And the classic signature for this would be the // pattern. So // or // patterns, depending if we're dealing with Linux or Windows. Now, the goal is usually to read sensitive configuration information like password hashes. So you may be looking for like etc password or win.ini. We're looking for some more special paths. So we'll normally see that. And so you do need to memorize that the sensitive targeted files for traversing on different operating systems. Like on Linux, we like to do the etc password or the etc shadow file. On Windows, they might be hitting the etc host file or the boot ini file or the win.ini file. Okay, these are the big things that we want to look at. Now, how do we see that traffic again? So when we're analyzing the logs for traversal attacks, we need to check the status codes to draw a conclusion. If we see the get .. then we know that they attempted it, but depending on their status code is depending on whether or not it worked. For instance, if we got a 404, you can conclude that it failed because the file was not found. But if they tried it and they got a 200, then they have a successful breach. The attacker was able to read the file. So remember, for the exam, HTTP response size is critical for a forensic investigator. Even if the status code is manipulated by an attacker, a sudden spike or drop in the byte size returned to a normal baseline file can confirm that data was exfiltrated. There are other types of errors where it may have said 404 or 403 for like forbidden, but what if it was a 403 forbidden, but in the error log was presented to the attacker itself and it presented the file anyway? So sometimes we may need to also double check these file sizes to see, was the data actually sent to them even though they got a 403. Now, file inclusion attacks allows attackers to execute scripts on a web server. And there's two different types of attacks. We got the local file inclusion or remote file inclusion. Local file inclusion is going to involve executing a file that is already present on the server. For instance, they might be looking for getting the Etsy password file. Remote file inclusion involves forcing the server to download and execute a script from an external attacker. For example, what if they were able to pull in evil.com/shell.txt? This is a remote file inclusion. Now, RFI's vulnerabilities are highly dangerous as they directly facilitate remote code execution. So if an attacker is allowed to introduce an entirely new malicious script on the target environment, well, that's going to be the worst for your environment itself. All right, once an attacker breaches a system, they're going to want persistence. Now, that's often achieved when we're looking at web shells. A web shell is a script, usually written in PHP or ASPX, uploaded by an attacker that acts as a command line interface to the web browser. Now, famous examples include the C99 shell and WSO. The primary function is to allow the attacker to upload files, run database queries, and execute OS-level commands. For the exam, make sure you're familiar with the China Chopper web shell. It is notorious for being extremely small, often one line of code, and it's very difficult to detect using traditional file-based antivirus solutions. When we're hunting for these web shells, we're usually looking for specific anomalies. We're going to be looking for creation times, and we're going to be looking for new files appearing in directories meant for upload, such as or anything named like PHP. Okay. We're also going to be looking for traffic patterns. We're going to be looking for the web shells generally. Web shells themselves generally have a low frequency but high impact to the system. They're often accessed only by a single specific external IP. So if you see that, normally that's going to be an issue. Now, high entropy, because shells are often obfuscated or encrypted, they're trying to avoid detection. They're going to yield a high entropy score compared to a normal readable code. So if we scan for entropy, we can normally find a high entropy thing. Now, high entropy in digital forensics refers to the measure of randomness in the file. Highly compressed or encrypted files will have an entropy score approaching 8.0. Now, this is something that we may want to use like autopsy to search within our database. Parameter tampering is manipulating the business logic of an application by changing hidden forms or URL parameters. For example, a normal request might be post buy.php and with an item and a price, while tampering might have changed that price maybe from $100 to $1. Now, if we can detect this correlation with an application log, then we can show that there has been request parameters that have been tampered with. This is technically categorized as business logic vulnerability. So on the exam, they might call this a business logic vulnerability. But from a forensics perspective, web logs might not show a full picture because we don't completely show posts for one. And for two, we may return a 200 OK back to the user. So the anomaly normally is only visible when you look within the application's backend database as well. Now, if we look at the attacker's frequency, we can try to detect whether or not they're using scanners. Okay, and if they're using scanners, then we can find things like, well, what kind of tools or attacks are they doing? And so we might be using the user agent part of this. So user agent string can help us identify the different types of tools that they might be using. And so this is built into all web logs. It tells you, hey, I'm using Chrome, I'm using Firefox. But what if it doesn't say that? What if it says SQL Map or Nikto? Okay, we may want to see what they're using. So SQL Map, for instance, would be like a SQL injection tool. Nikto would be a vulnerability scanner. Now, one of the big strings like this Mozilla 4.0 compatible, blah, 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 basically it's suspicious because they're trying to see if there's compatibility with old operating systems and old browsers. And a lot of malware bots will have it hard-coded, so they say they're Mozilla 4.0, and even though they're not. Okay, and if something else that's very suspicious, if it's missing all in all. Every known web browser has it built in, and it normally will actually be logged in the database. And now this helps web developers determine how to display their code onto the screen. And so if it being blank is very suspicious, it often indicates poorly written custom scripts. Now, while sophisticated attackers will easily spoof user agent to blend in with normal traffic, script kiddies and default scanner configurations often leave them unchanged. So this could help provide valuable and easy indicators of compromise for those who are preparing for the CISA Plus. All right. The next tool is going to be the log parser. This tool is a Microsoft tool. It's a critical tool in our forensics arsenal that's going to help us use command line utilities to query text logs. Now, if you're familiar with SQL, it looks a lot like SQL because it's a lot of SQL-like syntax. It's a great use for rapidly querying thousands of logs quickly to find specific IP addresses performing scans or hits on your systems. Now for the exam, make sure you familiarize yourself with the basic log parser syntax, because the exam may ask how a specific column like CIP or SC status from an IIS log is used for certain network behavior. So if you know that the status of 404, this telling me that this is a page not found, that might be in the exam itself. The next tool is going to be Burp Suite. Burp Suite is an industry standard web proxy. While primarily used by attackers and penetration testers, it has valid forensic uses as well. Investigators would use it to replay captured attacks in a safe environment to understand their impact, or for utilizing decoding tools to unravel complex payloads found in logs. So sometimes we want to regenerate those logs or regenerate how that log was generated in the first place so we can use it in the court. Now, understanding key concepts of intercepting proxies is something that you need to know for the exam, and know that in forensics, you might use Burp Suite functionality to quickly unravel URL encoded, like base64 encoded, or any other types of logs that were generated in our review. All right, the next tool is going to be Splunk or ELK. So these are SIMs. When operating enterprise scale, manual log review normally is impossible, so we need a SIM, a security information event management system. And we need to know Splunk and ELK. These are the two big ones that we should know about. Now, the nice thing about a SIM is it's going to aggregate all the logs into a centralized spot. It will help us correlate it to be like looking for SQL injection or database log syntax errors. And it also will give us dashboards so we can actually trend this on a graph or geographically, however we want to see it. Now, the exam will test your understanding of log aggregation and time synchronization, like knowing that NTP is how we normally would check for time synchronization, and that a SIM correlation capabilities is completely useless if the system clocks across the web tier are out of sync. Okay. If any of the three tiers are out of sync, well, the logs themselves are going to be useless to us. Now, finally, we need to be aware of anti-forensics techniques in web environments. So we may need to be able to say, hey, does it look like there was log wiping involved? Did they timestamp? Did they proxy chain? Could you tell if any of these happened? Now, anti-forensics is a major knowledge base of the CHFI. So knowing that timestamping manipulates MAC, modified access, and created times will often require deep analysis of the file allocation table on Windows to figure out, hey, what is the true timestamp of this file? Because remember, MFTs are the way that we would look further into it. All right, I know this chapter was very long. Thank you for sticking with me. So as a summary, we looked through a lot of web logs, but these web logs are very important, and they're the number one things that normally are going to get attacked from the internet standpoint. Okay. So as we looked through that, we did look through different ways. We also looked at a lot of different attacks and their signatures of what it would look like inside the logs. So just be aware that you can identify those. So log analysis and forensics is always going to be about establishing a definitive timeline of events, determining the full scope of breach, and help document the evidence. All right. Well, that's the end of chapter 9. See you for chapter 10 as we keep going through the forensics investigators.